Hello everyone, you're welcome to my channel. So in today's video I want to do a very simple down to complex project on SQL join. There are 11 tasks we are going to be doing in this video. It's all revolve around SQL join. First of all, I'm going to choose database to use. So I'll be using the SQL joins database. And if you come here, currently the database is on new schema. So I'll be changing it from new schema to SQL join. So I've successfully changed it to SQL join. The next thing I want to do is to create 3 tables. The syntax has already been outlined there. So the first one is the salesman table, second is the customer, and the third is the orders table. So I'll be creating this. If I run this, it's successful. I run the second one. Okay, let's see, customer already exists. Okay, so I'm going to, in order for me to understand what is happening, I want to delete the previous customer. So I'll drop the table. I run this, okay. Then I'll go back and I'll run it. I'll also go back and I'll run this. Okay. Now we are going to be inserting some rows of data into each of the tables. Now in the salesman table I'll be inserting just 6 rows of data. In the customer table I'll be inserting 8 rows of data, and then in the orders table I'm going to insert 12 rows of data. If I run this, you can see anytime you see the green check mark, it means the data as or the syntax was successful. Okay, and then I run this too, and I run this. I want to quickly just show us a table so that we get an idea of how it looks like. So we say select everything from salesman. We run the second one, select everything from customer. And then we write out the third one, select everything from orders. Okay, so if I run this, you can see this is the output. So that is the output of the salesman table. I run the customer. So you can see this is the output of the customer table. And then I run the third one, which is the orders. This is the output of the orders table. So we want to quickly run some analysis involving joins. So what I'm going to do is, since this query requires me to always take note of the syntax or the data type of these tables. So we start with a simple task. With a simple task, the first question says, from the following table, write a SQL query to find the salesperson and the customer who resides in the same city. Return salesman, customer name, and the city. So the first thing you want to take note of, anytime you have a query like this that tells you what to return, just know that your task has been simplified. Okay, it has been simplified. Now we want to select s dot name. We'll give it an alias as salesman. Okay, and then the next column we have to return is the customer name. So that becomes c dot cost underscore name. We'll give it an alias as customer name. And then the last column we have to return is the city. So that should be the customer city. So we'll say c dot city. We'll give it an alias again also. That is customer city. So you can see now the question says to find the salesperson and the customer who resides in the same city. So where are we taking this query from? We are using the salesperson table or the salesman table. So the salesman from salesman as S will be joining customer as C on. So anytime you are using join query usually works when they both have a similar column. So a particular column must be in the both tables. So on that basis, you can join tables together. So the column that is common to both salesman and customer ID is salesman ID. Okay, the salesman ID. So we are joining customer as C on s.salesman ID, which is also found in C. Okay, dot salesman ID. We run this. Okay, so you can see the salesperson and customer who reside in the same city. The salesman and the customer, they reside in the same city of New York. This and this reside in the same city of New York. Okay, so that is how the result is produced. So what we did here is what we call the inner join. So we are joining the both tables, okay, on the basis of the salesman ID. So when we perform an inner join, SQL is going to produce tables that are related based on these criteria. That is what we have here. So any results that does not tally based on this criteria will not be outputted. Okay, so that is for the first task. Now the second one says from the above tables write a SQL query to find those orders where the order amount exists between 500 and 2000. So we have to return the order number, purchase amount, customer name, and city. So we are going there to say select. First of all, it says order number. So the order number can be found in the order table. O.order underscore number. We'll give this an alias as order number. Then we have the purchase amount. The purchase amount can be found also in the orders table. So we say O. So we always, anytime you see a short form like O, like S, C, and the rest, so it's just like a short form of that table. So we are simply saying order number can be found in orders table. So instead of us writing orders in full, we'll simply denote it as O. So we say O dot purchase amount as purchased amount. and then we have the c dot cost name as customer name, and then we have the city. So the city is in, okay, still c dot city as customer city. Where are we taking this query from? Which table? So the first table we'll be taking it from is the orders table, from orders as O. Can you see that now? So the O we represented in the initial line on line 66 on the previous line is now being identified as the orders table. So from orders as O, we are joining customer as C. So then on what basis? So we say on the customer ID is common to the both tables. So we say O dot customer ID equals C dot customer ID. Now the query says where the order amount exists between 500 and what? And 2000. So we say where O dot purchase amount between 500 and 2000. Okay, so we'll run this, control and enter. So you can see, so this is the order number, this is the purchase amount, the customer name, and then the city. So you use the where clause to actually serve as the condition, okay, as a condition for the output. So the output, we want it to be between 500 and 2000. So the where clause helps you to produce an output based on the condition. Then in the third task, from the following table, write a SQL query to locate those salespeople who do not live in the same city where their customers live and have a commission of more than 12% from the company. So they do not live in the same city where their customers live and have commission of more than 12% from the company. So there are two conditions here. The first one is they do not live in the same city as their customer, and then commission of 12%. So what are we to return? Customer name, customer city, salesman, sales city, and then the commission. Now let's go select, what do we see? Customer name. So this becomes c dot customer cost underscore name as customer name, c dot city as customer city, then the salesman, it should be s dot name as salesman, then the salesman city should be s dot city as salesman city, and then the commission should be s dot commission as salesman commission. It's very important to all customize your column headers. It is not a must. Okay, this as is not a must, but anytime you run SQL query, instead of this customized column header, you are going to be seeing this. Okay, so just as you have the order number, purchase amount, customer name, customer city, you can see how orderly the result is. That was because I used all this as, and then the name as, and then the name as. So if I did not do that, you always see this c dot cost name, c dot city, s dot name, and it may make your result to look rough. So you want to ensure that your work is neat. So we say we are now okay. We'll take the table from customer
for
as
and freelance projects. Send me a DM via WhatsApp.
Okay, as C.
1277263.
So what are we doing? We are joining salesman as S on. So the common column between the both, the common column in the both tables. That is salesman ID on c dot salesman ID equals to s dot salesman ID. Okay, this is where the condition comes in. So where they do not live in the same city as in the same city where their customer lives. So that means c dot city, please watch this, is not equal to s dot city. Okay, so can you see that? So the city where the customer lives is c dot city, is not the same as where the salesperson lives, which is s dot city. And so we have the and function. So and I've received a commission of more than 12% from the company. So who received the commission? It is the salesman. So that means s dot name. Okay, no, not s dot name, s dot commission. S dot commission is greater than. Okay, so 12% is 0.12, and then we'll run this. So you can see, so these are the sales people that do not live in the same city. They don't live in the same city with their customer. So this customer, Graham Zuzi, is living in California, and then the salesperson is living in Paris. So the first condition has been met, and then the commission is greater than 12%. So you can say this is 0.13. Now we go over to the so we are now done with the simple tasks. All of all this that we've done, they are simple SQL tasks. Now let's go into the medium task. So in the medium task, we are going to be seeing examples where we are joining more than one table. So in this simple task, we've been joining just one table, as in like joining two tables. Yeah, so one table is joining the other. So but in the medium task, one table will be joining more than one table. So let's see the first one. It says, from the following table, write a SQL query to find the details of an order. So we want to write a SQL query to find the details of an order. So we have to return order number, order date, purchase amount, customer name, grade, salesman, and commission. Wow, this is quite a huge list of results. So let's go. Select. First on the line is order number, so this should be O dot odd underscore number. We'll give it an alias as odd number. Okay, then we have the order date o dot odd underscore date. Give it an alias as order dates. And then we have the next one, which is purchase amount, which is that should be in the column of orders also. So orders o dot purchase amount as purchase amount. And then what again? Customer name, so that should be c dot cost underscore name as customer name. The grade, that should be c dot grade as grade. So the salesman, that should be s dot name as salesman, salesman. And then commission, that should be s also dot commission as commission. So from orders as O, we are joining customer as C. So on what condition? On the common column in the both tables, that should be the customer ID. On O dot customer ID, which is equals to C dot customer ID. We are joining again salesman as S on O dot the column that is common to the both tables, orders and salesman. Okay, the salesman ID. S dot salesman underscore ID. So you can see these are the details of an order. The order that was placed, you can easily get their details here. The customer who placed the order, the amount that was placed, the dates, the salesman who attended to the customer, and the commission that the salesman got. We go to the next one. To write a SQL statement to join the table salesman, customer, and others, so that the same column of each table appear once and only relational rows are returned. So in this case, we are going to be selecting everything because no outputs. We are not asked to return specified columns. So we are just to join the tables, the three tables together, so that the same column of each table appear only once. Okay, they appear only once and only the relational rows are returned. So we are selecting everything from the first table is salesman as S. Now what are we doing here? We are doing what we call the natural join. Natural join customer as C. There is no condition when you work with natural join. Okay, there is no condition. You know, when I perform this inner join, you can see the condition on O.customer ID equals C.customer ID and all that. So all these are conditions. So, but in natural join, there is no condition. So we are naturally joining all of them. Natural join orders as O. So we run this. So you can see. So we selected everything, and these are the outputs that we've got. We'll go to the next task. So it says from the following table, write a SQL join to find those customers with a grade less than 300. We have to return this column, this one, this, and this. So that's 5 columns. The result should be ordered by ascending customer ID. So we will say select c.costName as customer name c.city as customer city then we have c.grade as grade, and then s.name as salesman, s.city as salesman city. So we had to from always ensure that your functions are in capital letter. It makes your SQL syntax to look organized. Okay, from customer as C, join salesman as S, so the common condition to the customer on the salesman is salesman ID. So we have C dot salesman ID equals S dot salesman ID. Now we are setting the condition where customers with grade less than. Okay, so the grade is C dot grade less than what? 300, and then we are ordering it. So we order by the customer ID. We say C dot customer ID ascending. So ascending is A, is for short is ASC. And then we close this, control and enter. So you can see This is the result. So these are the customers with less than 300 grade. So we'll be going ahead into the complex tax. We are asked to write a SQL statement to generate a report with customer name, city, order number, order date, order number, salesman, salesperson name, and commission to determine if any of the existing customers have not placed orders, or if they have placed orders through their salesman or by themselves. So I have to take note of something. There are two conditions here to determine if any of the existing customers have not placed orders. Okay, so have not placed orders, or if they have placed orders. So anytime you are working in SQL join and you see task that has to do with not, have not, or have, you know, that any task around that region. Okay, so in such instances you no longer use the inner join I have been using thus far. Okay, so you begin to look at the options of left join, right join, as the case may be, because it is when you use the left join, it is going to give you the result where the condition is true. Okay, where, for instance, this condition is true and other columns in the left table will be shown as the result. Now when you use the right join, it will give you the result where the condition is true and other columns on the right table, as in that is on the table on the right hand side. Okay, so where the result is not true, you are going to see a null value, as in you are going to see an empty kind of result to show you that the condition is not true. So we want to see that here. So we want to generate a report with customer name, city, order number, order date, order amount, salesperson. We are selecting customer name is c dot name, no cost name. One of the things you must take note of as customer name when working with SQL is, especially when you're working with join, your mind must be in what you are coding. You cannot multitask whenever you are writing SQL syntax, especially when it has to do with join, because remember, there are many tables in question and you wouldn't want to mix one table for the other, or you wouldn't want to give a parameter or a condition that would not give you the needed result. So you want to ensure that your mind and your heart is in the syntax you are writing. So we say select c.customer.cost name as customer name, then the next output is city. We'll say c.city as underscore cost, customer city, and then we have order number. Order number should be in the order date, yes, order table. O dot odd underscore number as order number. So you have O dot odd date as order date, the purchase amount. So we say O dot purchase underscore amount as let's leave it as order amount. Okay, what are the other conditions? Salesperson name and commission. So we have s dot name as salesperson name s dot commission as commission. Okay, then the next thing we want to do, we want to from customer as C. Now this is where we want to think critically on the type of join. So the question says SQL statement to generate a report with, all that to determine if the existing customers have not placed orders or have placed orders through their salesman or themselves. So when you take your time to think about it, customer is now on the left hand side of this query, okay, because we are taking from the customer. So any other table we are joining, it will be to the right hand side. Do you get it? So you want to, so just as I explained, if you use right join, it will give you the results where the condition is true and the columns on the right hand table. The left join will give you the results where the both conditions are true and the column on the left hand side of the left table. So we want to see the existing customers that have not placed orders. So that means we'll be performing the right join. Okay, so the right join will give us, if we do the right join, okay, right join orders as O, okay, on. So what is the column that is common to the both tables? So we see the salesman ID. So on C.salesman ID equals O.salesman ID. That means as we have chosen this right join, it will give us even customers that have not placed orders. Just a second, let me confirm something here to determine if any of the existing customers have not. Okay, I'm going to retract. I think this should be left. This should be left, please. This should be left. Okay, it is left because it will determine if any of the existing customers. So it will give us the customers. Okay, remember the customer is on the left hand side. So the customers that have placed orders, including the ones who have not placed orders. Okay, so that is why. So both the condition, it will give us the result where this condition is true and where they have not yet placed orders, if at all if at all such columns are available, it will output the result. So that is why we are going to use the left join. Also, we'll use the left join on the salesman as S on Okay, the common column to the both of them is salesman and customer. That is the salesman ID also. We say c.salesman equals s.salesman. Okay, and then we run this. Oh my. So these are the results you can see. So that means all the customers here, they've placed orders already. If there are customers at all that did not place order, you will see the order number will be null. They will show up, but you see the order number to be null. Okay. So the last but not the least, from the following table, write a SQL query to list all salesperson along with the customer name. Okay, all about this. Condition for selecting list of salesmen who work for one or more. Can you see that? And then salesmen who not yet joined under any customer. Condition for selecting list of customer. Be placed one or more orders or no order placed to their salesman. So these are two conditions. I want to simply go over them. So in order to save time and all that, so let me see this 1, 2, 3, 4, 5 and 6. So let me see how I can pick them from here. Select customer name, customer city. Okay, I'll just drag them in. So we've gotten customer name and customer city. Then we have the grade, order number, dates, and amount. Order number, dates, and amounts. Okay. So I think these are. So use the control and the left button, left mouse button. To copy. So we are left with this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So we are left with the grade. So the grade is in the customer table. So we say C dot grade as grade. Okay, so let's see what we have here. So we say from customer as C. Now let's look at it. Condition for selecting list of salesmen. So we have to list all salesperson. It borders on the salespersons actually. So if we are to list the salesperson, that means we are left joining on the salesperson. So we'll say salesman as S left join customer as C. On what's the column common to the both of them? We have the salesman ID on S.salesman ID equals c.salesman ID. We are also left joining the orders table. O on S dot. So let's look at what is common to the salesman and orders. Also the salesman ID. O dot salesman ID, and then we'll run this. Okay, so you can see, so these are the to list all salespersons. There's supposed to be an additional sales persons, s dot sales s dot name, let me fix it here, s dot name as sales man, and then this is o dot add underscore number as. So if I run this again, so you can see, so these are the sales people along with their customer name. You can see these are their customer name, and the salesmen who work for one or more customers. So these are the, this is salesman Pete Alex worked for Brad Guzan, so one or more. So the condition is that they must work for one or more customers. So if not that it has to do with one, if it were to be like just more than one customer, it would have been another syntax where the where clause would have come in, and then salesman who are here to join under any customer. And then the condition for listing of customer is that it must place one. Can you see that? So Nick Raimondo placed one order. Oh, sorry, Brad Guzan placed one order. So no order was placed. No order was placed to their salesman. So there is no any customer who did not place order to their salesman. Every one of them placed order to their salesman. That is why you are not seeing any null value. If this condition is to be true, you see a salesman, but there will be no customer under, and there will be no customer name in the same row. You will see a null value if this condition is to be true. But because this condition is not true, that is why you can see, or is not existing. That is why you can see the projects, or you can see the output. So this is all we can be able to take for the SQL join. I sincerely hope you have learned something new. I'm going to be pasting this SQL file on my GitHub channel, so you can take your time and go through it and get yourself acquainted with the rudiments of writing SQL syntax in my SQL workbench. So I'm going to recap just a few things. The first one is, anytime you are writing SQL join, you must ensure that one, your mind is there, your heart is there. There is no division of your mind. Okay, you are not multitasking whenever you are coding in MySQL. Then the second is that you must take notes of when you are to join more than one table. Third is you must know the kind of join to make depending on the result you want to get. Depending on the task you are given, you must know the kind of join to use, when to use inner join, when to use the right join, and also when to use the left join. So I think those are the few take home you would want to apply. Please, if you have not subscribed to my channel, do well to subscribe. It really encourages me a lot.
For trainings and freelance projects, send me a DM via WhatsApp, +234 810 127 7263.
I'll see you next time.